Waves are disturbances that transport energy from one location to another without transportation of matter. Waves, which require a material medium for their propagation, are called mechanical waves. For the next part of this presentation, I will use the term waves to refer to mechanical waves. Waves are able to propagate through a medium because of the interaction forces between the particles of the medium. These particles could be atoms or molecules. To understand wave propagation, it is good to imagine the particles of the medium as connected by springs. The springs may represent the interaction forces between the particles of the medium. Let us first consider transverse waves. They are waves which make the particles of the medium vibrate perpendicular to the direction of the wave motion. How can transverse waves propagate through a medium? When your hand pulls up the first particle of the medium, the next particle also feels the upward pull of your hand through a spring linking the two particles. The same thing happens to the third particle. The particles of the medium do not move at the same time because of inertia. Inertia is the tendency of objects to resist change in motion. Because of inertia, the particles appear like giving a delayed reaction. It takes time before they could move when acted upon by a force. When the particles are heavier, they tend to have greater inertia. Waves move slower when the medium has greater mass. Similarly, if the first particle is pulled down, it also pulls down the particle next to it. The forces between the particles enable them to influence the motion of those next to them and, in effect, pass the disturbance that they experienced or felt to neighboring particles. The particles of the medium return to their undisturbed positions also because of these forces. But the energy used in creating the wave is carried up to the end of the medium. The particles of the medium are not carried along by the propagating waves. Now let us consider longitudinal waves. They are waves that make the particles of the medium vibrate parallel to the direction of wave motion. When you pull and push alternately one end of the medium, the first particle of the medium moves left and right from its original position. The push and pull on the first particle are also felt by the next particles through the spring linking them. Each particle then moves left and right in succession as the waves propagate. But then again, the particles of the medium are not carried along by the propagating waves. Do you know now why they do not move at the same time? Remember the magic word inertia.